Hey everybody, welcome to Eureka Math / Engage in New York Math, Module 6, Lesson 8, Variability in a Data Distribution. So a few things we're going to talk about today, and this should be a very short video because I want to look at even some more examples in class and be able to work through some of these together. But this is just going to be a very quick lesson, and of course then I'll talk for 10 minutes, but I think it'll be very quick. I want to look at the mean of a data set as a typical value. Like this is typically what something is. Whether that's accurate or not kind of depends upon the distribution. Like we don't only look at the center of the distribution, but we look at the variability or the spread of numbers, like how far apart they are. Some numbers may have the same, or some data sets may have the same mean, but they may differ in variability. So it's important to not just look at data and look at it as a number, as a set of numbers, but look at what those numbers really mean. All right. So let's get started. We're going to look. Here's an example here, and I'm going to read it to you. Robert's family is planning to move either to New York City or San Francisco. Robert has a cousin in San Francisco and asks her how she likes living in a climate as warm as San Francisco. She replied that it doesn't get very warm in San Francisco. He was surprised by her answer. Because temperature was one of the criteria he was going to use to form his opinion about where to move, he decided to investigate the temperature distributions for New York City and San Francisco. The table below gives average temperatures in degrees Fahrenheit for each of the months between the two cities. So here we have January, February, March, April, right? And if you go across, here's all the New York average temperatures. Here's all the San Francisco average temperatures. And San Francisco is very cool because of the bay, right? So it has that ocean wind coming in. So that's actually legitimate. So look at the data here and tell me what you notice. New York in January, the average is 39 degrees, very cold. San Francisco is 57, which is still cool, but not all that cold. As we go across, New York is 42, San Francisco is 60 in February, March 50 and 62, April 61 and 63, May 71 and 64, and let's jump into July, one of the hotter months, right? In New York, the average is 85 degrees. In San Francisco, the average is 67. Well, if we look over here, let's just look at San Francisco. 57, 60, 62, 63, 64, 67, 67, 68, 70. That's our high water mark, right? September is the hottest on average month in San Francisco according to this data. 70 degrees, 69, 63. December, 58. Our data, based on the averages, only ranges from, let's see, the lowest would be 57 as a low point to 70 as a high point. So for San Francisco, your average, again, there are going to be days that are colder and hotter, right? But your average goes from 57 to 70. There's only a 13-degree difference in the average cool temperatures and hot temperatures. If we look at New York, on the other hand, we go 39, 42, 50, 61, like here we're jumping 8, we're jumping 11, 71, we jump 10, 81, we jump another 10, 85, 84, we're starting to drop, 76, we're dropping 8, 65 dropped 11, 55 dropped 10, 47 dropped 8. So very different, right? In the summer, it's very hot. In the winter months, it's colder, right? And so our low for New York, looks like our low is average is 39, and then our average, the highest average looks like it was in July, which is 85. So whereas San Francisco, the difference is only 13. In New York, the difference is 46. 46 degrees difference between the coldest months and the hottest months. San Francisco, it's only 13 degrees. Not that significant. So having said that, we have calculated this for you. If you count up all the degrees, so 39 plus 42 plus 50 for New York, and then divide it by the number of data sets, or the number in the data set, 12, you're going to get an average for New York. Average temperature for New York City is 63 degrees across the whole year. For San Francisco, if you add all those up and divide them by 12, average temperature is 64 degrees. So if we look at the average temperature, it looks like New York and San Francisco have about the same temperature and about the same weather across the entire year. But because we looked at the data and we said, what does that really mean, right? We know that's not the case at all. New York goes from very cold to very hot, back to very cold, going from January to summer to December again. San Francisco goes from cool to a little warmer to a little cooler. It's not that big of a change. So in this case, the mean, if he just looked at the average temperature, he'd say, oh, I can move to either place. They're about the same. But you have to look further into the data because there's a lot more variability. But if we're looking at the mean only accurately represents one of these two cities. So let's take a look. So this is a dot plot of the temperatures for New York City across the 12 months right here. Down below, we have San Francisco. Well, the averages are basically the same. We said New York was the average of 63 degrees Fahrenheit across the year. San Francisco was 1 degree difference, which was 64 across the entire year. But if you notice, San Francisco's are all clustered, right? Their temperatures throughout the year are all basically in this small little range that looks like it's usually in the 60s, right? A little bit gets into the 50s, a little bit gets into the 70s, or one data point gets into the 70s, but it's basically clustered around 63, 64 degrees. Well, obviously 64 being the average. So in this case, the average is an accurate way to represent the data from San Francisco, because 64, that's about where most of the data would fall, right, if we balance that out. But in New York, if our average is 63, which is right here, we have a bunch of data really far away from it on the right and a bunch of data really far away from that on the left. And so, yes, the 40s and the 80s kind of meet in the middle, but if you go to San Francisco thinking it's going to be 64 degrees, chances are many months you're going to be pretty darn close. If you go to New York thinking it's going to be 63 degrees, it's only going to be 63 degrees during a few times of the year. Sometimes it may be freezing, and other times it may be really warm or really hot. So this is called variability in the data, and we have to look at the data to see, is the mean an accurate representation of the data? Does it make sense to look at the mean? So the mean for San Francisco, it does make sense because it's accurate. If you're looking at the mean of New York City, it is not an accurate representation of that data. So I know that's kind of surface level. We're going to look at a little bit more of this together, and we'll talk about it more in class, and we'll do some more examples. But I just want you to see that the mean is, if you say that the mean is kind of, well, it represents the numbers most of the time. In San Francisco, it does. 64, it's usually around 64 most of the time. In New York, the mean is a bad example of data. And in fact, in Kansas, or Kansas City, where we live, the mean would also be a bad look at the data, because we have times in August, July, where we're having these 100-degree days or 95-degree days, and it feels like, we're in the 90s. And then we get into January, February, and then we have these days where it's 20 degrees or in the teens, right? And so the average temperature for the year would not make sense to look at places like New York or Kansas City, because we have a lot of variability. That varies a lot, it changes a lot, right? In San Francisco, the temperatures are pretty much the same a lot of the time, so the mean would make sense. So it's just a matter of knowing when the mean makes sense. Okay, thanks for watching. We'll talk more about this in class, and we'll see you soon.